Bismillahirrahmanirrahim. Let's review the one-dimensional simplex element before easing into its 2D and 3D counterparts. This, if you recall, we have already done in the introduction. Now, the displacement function will be, for a 1D element will be this, and what we are talking about is an element with two nodes and this phi I here, and in this case 1D phi is equal to u, so you can use it interchangeably. Phi I, phi j, there's an origin here and the coordinate of the I node is xi, whereas the coordinate of the j node is xj, and this being the difference between xj and xi, the length. Now the first task is to calculate the coefficients alpha 1 and alpha 2. So we have two nodes, that is easy. Write this phi in terms of node I and node j. This is alpha 1 plus alpha 2 xi. Phi j will be alpha 1 plus alpha 2 xj. Now we can rewrite this in a more convenient form, matrix form. Like this, or symbolically, let's call it X matrix. This is the alpha matrix. Now, because we are interested in finding alpha values, so let's rewrite it, take it to the left hand side. This is more convenient for us. So it all boils down to taking the inverse of the matrix X. Now, for a 2 by 2 matrix, the procedure is very simple. If the matrix is A, B, C, D, then the inverse is simply taking the determinant of A in the denominator, followed by interchanging D and A and changing the signs of B and C. That's all you have to do. So if that is applied to our matrix, then the result is, this is the determinant followed by doing the necessary changes inside the matrix. And because xj minus xi is length, this becomes 1 over L xj minus xi minus 1, 1. This is your inverse of the X matrix. Now, coming back, this is the expression for the alpha vector. Now, if we again take the original displacement function, the original function was this, which again can be written in matrix form very conveniently, like this. So we have this one, we have the expression for. We just put in the values, so we get 1x followed by 1 over L xj minus xi minus 1, 1 phi I phi j. Rearranging, taking L to the left and multiplying these two matrices, we get xj minus x minus xi phi I phi j, or a very familiar expression for you because we have already done it, you would recall. This is 5. Now, putting in any value of x will give you the displacement at that point for this element, or we can simplify it like this. where ni was xj minus x over L and nj is x over x minus xi over L. So this is very familiar for you. These are the shape functions for a 1D simplex element. Now let us come back to our figure here, and this linear function or its final form that we have achieved, this merely means that there is a value of phi here and there is another value of phi here, which have a linear relationship. As you move along x, the value changes linearly. Now let us observe some properties of n. Some properties of shape functions. First of all, there are two in number. This will correspond to the number of nodes, equal to number of nodes. This is the first property. The second property is at I node, ni is equal to 1 and nj is equal to 0. Whereas at j node, nj is equal to 1 and ni is equal to 0. Can we check this? Let's see. Ni is equal to xj minus x over L. Now, at I node, x is equal to xi. At I node, and I will become xj minus xi. X is a variable. Now it will take the form of xi. Now xj minus xi is equal to length. So it is L over L is equal to 1. Can we check that nj is equal to 0 at I node? Again, nj is x minus xi over L, and x takes the value xi at I node. So xi minus xi 0, 0 over L is equal to 0. And the same thing can be checked at node j as well. Now we come to the third property. The third property is, this is 1, this is 2, and the third property is anywhere in the element ni plus nj equals to 1. Now on the two nodes, sure enough, we have just checked 1 plus 0 or 0 plus 1. On the two nodes, this holds, but this also holds throughout the element. Can we prove that? Let's write the expressions for xj minus xi over L plus x minus xi over L. This is basically ni plus nj. X gets cancelled with the other x, so you get xj minus xi over L. Again, xj minus xi is equal to L, so L over L, this means this is 1. So we have again proved this. If this is the element, all these three properties, what they tell us is ni is equal to 1 at node I, whereas ni is equal to 0 at node j. Similarly, at node j, nj is equal to 1, whereas at node I, nj is equal to 0. And because it's a linear interpolation function, the manner in which it goes to 0 is linear, and the same goes here. It is very obvious that at a point in between, at the midpoint, both ni and nj should be equal to 0.5 each. Similarly, if you select the midpoint and the node j, then you can, because it's a linear interpolation function, you can say that here nj will be 0.75, whereas ni will be 0.25. Let's take up a problem now to demonstrate the utility of shape function and the displacement function. Recall that for 1D problem, I and u are equivalent, and we are only interested in the u component of displacement. Now let's draw this schematically so that you know what we're talking about. This is the element, two nodes here, phi 1 or phi I or ui is the same thing. Ui is equal to 0.12 millimeters and uj is equal to 0.08 millimeters. A little consideration will show that this element is in compression. Now this is the origin, and the coordinate, x coordinate is of I node is 30 millimeters, and the coordinate for j node is 50 millimeters here. Now the length will of course be 50 minus 30. This is the length, 20 millimeters. Now we need to first of all calculate the shape function. It's just a matter of putting in the values. I xj minus x over L. Xj is 50, x is variable, length is 50 minus 30, 20, or we can write it like 2.5 minus 0.05x. This is the value of ni. Now, nj is x minus xi over L. X is a variable, xi is 30, length is 20. Now you can write this as 0.05x minus 1.5. So these are the shape functions. Now we take up part B. Part B is the interpolation model for displacement for this element. It's very simple. U, again phi and u are the same thing for 1D. Ni, nj, ui, uj. This is the displacement function. You know the values of ni and nj, you just calculated them. 2.5 minus 0.05x, 0.05x minus 1.5, and here the values. You could substitute the numbers here, but either way it is all right. So you have just done part B also. This is the interpolation model because you put in the value of x, any value of x. It should be valid. That is, the value of x must be between 30 and 50 because that is the domain of this element. Any value here, and you can check this. You put the value of x equal to 30. That means node I. So this should become 1 and this should become 0. Vice versa. If you put the values of value of x is equal to 50, that means you're talking about the j node. So you'll get 0 on the left and 1 on the right. And that has to be so because at I node, the value of u should be equal to ui. That will only happen if ni becomes 1 and nj becomes 0. Similarly, at j node, the value of u should be equal to uj, and that is only possible if nj becomes 1 and ni becomes 0. Part C, he wants us to calculate the displacement value at x is equal to 45. It's a simple matter of putting in x is equal to 45 in the above expression. Now, before we do that, let's see what should we expect. What about midpoint here? the coordinate would be 40 here, and because the linear displacement function, it is very easy to see that the displacement here should be 0.1 millimeter. And what about midpoint between now this 40 and 50? This is 45. So you're talking about an average of 0.1 and 0.08. So it should be 0.09 millimeter, because recall that this is a linear function we are talking about. This is whatever the value here and whatever the value here, you are basically connecting them with a straight line. Now let's see if we get 0.09. Putting in the values, 2.5 minus 0.05 into 45. Here we have 0.05, 45 minus 1.5, and we can just put in the values now. 0.12, 0.08. Now this turns out to be, on calculation, this turns out to be 0.25, and this is 0.75, as was expected. What we're talking about is if you go from 30 to 50, then 45 means 3/4 of the way. It is closer to J node, so 0.75 goes there. It is far from the I node, so it's 0.25. So it makes all the sense in the world. 0.12, 0.08, and a simple calculation will give you the result as 0.09 millimeters, which was what we expected.